So now we are on lesson 14. This is printed on your paper, correct? Yes. The paper that I passed out. Okay, great. So Diego is solving this system of equations. Here is his work. What did he do? Did he use the substitution method? No, what does it look like he did?
He used the two equations that he had.
No,
And we just like he did 4x minus.
he added them together. 4x minus 4x is 0. 3y plus 5y is 8y. 10 plus 6 is 16. And then he got y. Well, let's talk about that, can we? So he got that y equals 2, and then he substituted the 2 back into one of the equations for the y, and solved, and got x equals 1. So what did Diego do to solve the system? He added the equations together. And then is the pair of x and y values that Diego found actually a solution to the system? So think about that. Don't say it yet. Is the x and y that he found an actual solution to the system? So yell it out. Just think about it. Yeah, it is the one that we're working on. All right, so is the 1, 2 a solution to this system? And how did you verify that it's a solution? Anyone plug these equations into Desmos and see where they cross? So you could have verified by graphing. How else could you verify? Like by doing the substitution method or by plugging the x and y in? Good, because if these are the solutions, they would produce equivalent stuff on each side of the equal sign. So like 4 times 1 plus 3 times 2 equals 10, is that right? Yeah, what's 4 times 1?
4.
What's 3 times 2? Do those equal 10? Yes. And then if you plug it into the second one, -4 times 1 plus 5 times 2, does that equal 6? What's -4 times 1? -4. What's 5 times 2? And combined, does that give me a +6? Yes. So you can verify by plugging in the solution. You can verify, I don't know if that's easy. You can verify by graphing. But yeah, he did get the right solution. So does his method work for solving these systems? Yes. Will it work every time? No. Well, that's where it's debatable, because we don't know yet. But if I were to take an equation, like here we got 6 equals 6. If I were to add or subtract the same amount on both sides, is it still a true equation?
Yes.
Well, let's see. What if I want to add a 1 on each side? Is it still true?
Yep.
What if I want to multiply a 3 on each side? Is it still true? So we learned before that as long as I do it to both sides, then I do whatever I want. Good. So by adding these together, we know that whatever this expression equals is 6, like these are equal, right? Yeah. Yes, because they have an equal sign in between. If I add the same amount, so they're both the same amount, to each side of the equal sign, I'm not changing anything. So that's why it works. So let's do a few examples. All right, so we're gonna use Diego's method to solve these systems. So could I add these together and get rid of one of the variables? What variable would be eliminated?
Y.
Good, because 1y minus y equals 0. So what's 2x plus x? What's 4 plus 11? Opposite of multiplying 3 and whatever you do on one side. And yeah, x equals 5. Good. We still have to solve for the y. So how do I solve for y? And which equation do you think would be easiest to plug into? I agree. I think the bottom one. So I'm going to plug it into that one. 5 minus y equals 11. Get the y by itself. How do I cancel a positive 5? Do that on each side. I get negative y equals, is the y by itself?
Fair enough.
What needs to go away? Do you know how?
Divide.
And whatever you do on one side. Good. And if you didn't catch that, it's because what's the number in front if it's not written?
1.
So it happens to be a negative 1. That needs to go. It goes by dividing. So y equals 36. And did you still get y equals negative 6? So you can see, like, doesn't matter. As long as they're not breaking any numbers. So questions on A. Now, can I add the two equations together in B?
No.
Would that eliminate one of the variables, adding them together?
No.
Well, yeah, 2 of them have 8 in front, but they're both positive, so that wouldn't help me. What could I do instead? Yeah, because in those examples I was telling you where it was 6 equals 6, weren't we allowed to subtract the same amount on each side? So why can't we do that here? So let's do that. What's 8x minus 8x? 0 goes away. What's 11y minus y?
10y.
10y. So I have 11y, then I take away one of them, I have 10 left. And what's 37 minus 7? Solve for y. What's opposite of multiplying 10? Good. What does y equal 3? All right, so my coordinate is something comma 3, so y goes second. I need to solve for which one do you think would be easier to plug the y into second? I agree. Does it really matter? No. So we'll plug it into the second one because it looks like there's fewer stuff going on. So I get 8x plus 3 equals 7. And then solve for x. Would I get rid of the 8 or the 3 first? How do I make the 3 cancel? And then do on one side. Then 8x equals 4. Opposite of multiplying 8. Do that on both sides. What does x equal? 1. 0.5 or as a fraction. Good. I'll use the decimals and we would normally have it as a point. So questions on that? So that's actually the third method that I told you about. We already learned my graphing. We already learned my substitution. Guess what this method's called? Elimination. Because we're eliminating one of the variables by adding or subtracting the two equations together. And then once you solve for it, you substitute it back in to find the other one. Good? All right, I'll give you a couple to try. We already did these two. All right, we already did that. So here's how we can split it up. I'll have this side solve system A. If you're in the middle, solve system B. And if you're on the right side of the room, solve system C. Yeah. So try that. All right, so everyone look at the screen and don't pack up until I tell you to. But what you were asked to do was to graph whatever set of equations you were assigned. So if I had system A, I would graph both. And then you were also supposed to graph the equation that you got from adding them together and see what happens. So when I added the equations together, I got 8y equals 16. And guess what? Where do all the lines intersect? At 1, 2. And then once you did the same with the others, you got the same solution you would have had. But then once you graph that additional line, does it also cut through the same intersection? Yes. So that's what you're going to observe. So I'm not changing anything. But that is how you solve by elimination. So I'm not changing any of the solutions or anything by adding them together. I'm just making it easier to solve for one of the variables. Questions on that? All right, tomorrow I'll also leave you with a video from last year in case you need additional practice with elimination. But you'll be working on puzzle pieces all tomorrow, just so you know, for 13 and 14 and whatever else you're missing.